Assalamu alaikum. So the lesson today is about quadratic function and its graph. So today we are going to learn how to graph, in fact, the steps needed to graph a quadratic function, and we are going to define each steps. So first thing, let's start with the definition of a quadratic function. So definition. So what is a quadratic function? A quadratic function is a function defined by f of x equal ax squared plus bx plus c. So this is what is the quadratic function. So quadratic function is a function defined by f of x equal ax squared plus bx plus c, or some book they use y equal ax squared plus bx plus c. In fact, they are the same notation. There's no difference. Where a and b and c are, remember, such that a is not equal to 0, where a, b, and c are real number and a not equal to 0, because if a equals 0, we'll end up having a linear equation, so not equal to 0. Alright, let me give you an example of quadratic function. So for example, we can have f of x equal to x squared plus 5, or y equal x squared, or y equal minus x squared plus 4x plus 7, sorry, y equal x squared minus 9, half of x equal 5x squared, or alright, minus 5x squared, and so on. So those are example of quadratic function. So just a note on the side. So this is a note, or a remark if you want to call it remark. So the graph of every quadratic function is called parabola. So the graph of every quadratic function is called parabola. And it's look like this shape. Just this is just an example of a shape. Either it's look like this, for example, this is a parabola, or it can go down, or on the opening is on the right side or the left side. So just an example, it's look like this. So you can rotate this and it can take any direction you want. So this is how we uh, name the graph of a quadratic function. So the second note I want you to know is about the discriminant of the quadratic function. So with the discriminant, if you know the discriminant and you know the leading coefficient of the quadratic function, so those two can give you all the information you need to know about the quadratic graph or the parabola. So the discriminant leading coefficient. Of course, I'm talking about A, which is the first, which is the coefficient of x squared, the leading coefficient A. So can tell you anything you know about, or can inform you anything you know about the quadratic. So we need to know about the quadratic function. So how is that? We will see it. So you will see everything. Okay, so I just want you to have those information. So now we're going to talk about all the information or steps you need to know in order for you to graph a good parabola. So now the information. So so the steps needed to graph a parabola. So let me use new page. So the first steps is a domain. So first thing, know your domain. So what is a domain in fact? The domain is a set of all x coordinates that have a y coordinate. So that's exactly what is the domain. So the domain is the set of all x coordinates that have a y coordinate. So what do I mean by that? I mean if x is always your input of the function, y is your output. So if I have an input that has an output, so that input is part of the domain. But if I have an input that does not have an output, that means that input is not part of the domain. So this is exactly what I mean by the domain. So all the inputs that have an output. So that means if I have a, if I have f of a equal b, so that means this is the output of a. So that means a is part of the domain. But if I have, for example, f of c is undefined, that means C is not part of the domain. So C not in the domain, but A is in the domain. So that's the idea about the definition. And this is a note of the domain. So keep in mind that the domain of every point of every quadratic function is already a number. So the domain, so you don't have to look for the domain because every input in a quadratic function has an output. So the domain of every quadratic function is all, remember. we always take this notation. D, which refers to the first letter of domain, is minus infinite, infinite, and this is how we express or renumber, is from negative infinite to infinite. So this is the first uh, steps. The second steps, we are going to talk about the vertex. So what is a vertex? So a vertex in fact is a point in the graph that either hold the maximum value of the output, which is a y coordinate, or a minimum value of the output. So it's exactly what is a vertex. So a vertex, so vertex is a point, which means it has a y coordinate and x coordinate. You see, it's not a value, it's a point. You see, a lot of people, they get confused about this. A point, it has coordinate. A value is just a number that has, it's not a coordinate. That's mean I'm talking about point that has two coordinates, x and y. So is a point in the graph that hold either a maximum y coordinate or a minimum y coordinate, that hold either a maximum y coordinate or a minimum. So in terms of graph, how it look like this. I will show you both graph for the maximum and the minimum. Either you see if the graph look like this. You see, for example, this is my vertex. So this is the vertex, and it's a minimum. You see, it's the minimum y value here. So all the y value are above that point. Or it can be like this, where it's hold a maximum y value, you see. So this is the point, and this is the maximum y value. So this is my vertex. So either it's a minimum or a maximum. So how to find out the vertex? So this is how we find the vertex. So the vertex is a point which has x coordinates. So the x, it's minus b over 2a. And the y is you plug in this into the function. That means you substitute minus b over 2a to get a. But if you want to know with the coefficient of x what is f of minus b over 2a, is the following, is just minus the discriminant over 4a. So if you find the discriminant, just put the discriminant here, use the opposite sign of the discriminant, then divide by 4a. It will give you the y value of the vertex, or the y coordinate of the vertex, and the x coordinate of the vertex is minus b over 2a. So the vertex can be either a max or a minimum point. You see, look at here, it's a minimum point or is a maximum point. Any point I pick here, you see, is above that point. Any point I pick is above that point. You see, any point I pick on the graph is always above that point. Any point I pick on this graph is below that point. You see, this is the maximum point, this is the maximum, and this is the minimum. So the vertex can be either the maximum point or the minimum. So how do I know if it's max or min? So if a, which is the leading coefficient, is positive, so the vertex is a minimum. Then the vertex is a minimum point, which means that in that case we have a here is positive, so this will be the minimum. For that case, a here is negative. So if a is negative, then the vertex is a maximum. If a is negative, then the vertex is a maximum point. So this is about the vertex. The third property is the range. So you need to know what is your range. So your range is the set of all output of the input. That means the set of all y coordinates. So this is exactly what is the range. The range is the set of all y coordinates. So for a quadratic function, so f of x equal ax squared plus bx plus c. So we have two type of range, and the range depend on the leading coefficient. So the range depend on that coefficient a. So first type, so if a is positive, so then the range, let me use the right, so then the range would be equal to minus the domain over 4a infinite. And if a is positive, if a is negative, sorry, then the range will be equal to minus infinite minus the domain over minus the discriminant over a. So we put this bracket because we include the that that value. So this, you see, a is negative. That means this is a maximum and the maximum value, and this is a minimum value if a is positive. So those are the type of range you may meet with. So either you have that one or you have that one. So this depends on the sign of a, if it's positive or negative. So for example, so if I have my function, so if f of x equal x squared minus 6x plus 5, so my range for that function is minus 4 infinite. A is positive, so I will have that type of range. And if I have a function defined by minus x squared plus 4x plus 1, so my range will be, so I will have that type, so it's going to be minus infinite 5. So those are the two examples that show you either we have that type of range or we have that type of range, depend on the sign of the leading coefficient a. So this is about the range. The fourth steps is axe of symmetry. So what is an axe of symmetry? An axe of symmetry is a line that cut the graph into two identical par or congruent par if you want to use the geometric terms. So axe of symmetry is a line uh, that cut the graph into two identical par. It's like a mirror, so this is exactly what I mean by that. So the left side and the right side are almost like identical, they're the same. So for the quadratic function, so if I have a quadratic function. So the axis of symmetry is the x coordinate of the vertex if f of x equal x squared plus bx plus c. So then its axis of symmetry is the x coordinate of the vertex, is the x coordinate of the vertex, which means that my axis of symmetry would be x equal minus b over 2a. So this is my axis of symmetry, and in the graph it's going to look like this. So if I have my parabola, so for example this is my axis of symmetry, so when I draw my parabola I just draw half of the parabola, and the other half I just do it by symmetry to get the whole graph. This is just an example. I know this side is not the same thing as the side, but keep it as just an example. Alright, so for example, if I want to find out the vertex, the axis of symmetry of this quadratic function, so example. So if I have f of x equal x squared minus 4x plus 4, so my axis of symmetry so will be x equals, so this is my b, you see my b is minus 4a, and a is 1, so it's going to be minus 4 over 1 over 2a, which is 2 times 1, so it's going to be 4 over 2, which is 2. So x equal to is my axis of symmetry. So before the last steps, we have concavity. So we talk about the concavity. So concavity, in fact, is the opening of the graph. Either the graph is opening wide up or is opening wide down. So this is about the concavity. So the concavity is the opening of the graph. The concavity is the opening of the graph. So if my function, so given f of x equal ax squared plus bx plus c, so if, so let me change the color of a because I'm going to use a, I want you to notice this. So if a is positive, then the graph is opening up, so we call this concave up. So then ax squared plus bx plus c is concave up, which means it's going to look like this. The graph will be opening up. So this is concave up. And if a is less than 0, so the graph is concave down. Then ax squared plus bx plus c is concave down. So it's going to look like this. So concave down. So this is about the concavity. The last thing I want to talk is about the x-intercept and y-intercept. So the intercept. So we have two intercepts. So the x-intercept are the x value found by making the quadratic function equal 0 by making ax squared plus bx plus c, so equals 0. That's mean useful for the quadratic equations. So the x value will be your x-intercept. So x-intercept mean the point that is gonna the graph cross on the x-axis. So for example here, if I have a graph and if I have this, you see, those points are called the x-intercept. X-intercept. And the point that cross the y here, this one is called the y-intercept. So, so this is about the x-intercept, and the y-intercept is the y value that crossed by the graph. So the y-intercept is the y value crossed by the graph. In fact, for the x-intercept, either we have one x-intercept, we have two x-intercept, or we have zero x-intercept. So there is cases for the y-intercept. You always have a y-intercept all the times, and the c value, which is the this value, is your y-intercept all the time. If there is any, if there is no c, that means zero. So y equals c is your y-intercept. For the x-intercept, I say it may be 1, 2, or 3. It depends about the discriminant. So we will see this in the coming lesson, inshallah. So this is about the introduction of the graph of the quadratic function. So I hope you got the main idea behind. So the next lesson, inshallah, we will see the application of those in a function, and we are going to learn how to graph those functions using those steps, inshallah. So thank you for watching the video, and I hope if you have any comment you will post it, so it's gonna help me improve my way of teaching. And thank you again for watching the video, and Assalamu alaikum.